everyone. I hope you are fine and doing well. So today I come up with another series of my lecture of mathematics of cryptography. So today we will discuss some Boolean function that is based on Galois field. So why I'm going to discuss Galois field and why we have discussed lastly the Boolean function that are just based on vector space or binary field, that is Z2. So let me elaborate the Galois field and then primitive irreducible polynomials, and then we will discuss substitution boxes or substitution boxes as a multivalued Boolean function. So let me elaborate this with today the topic of our discussion is again I must say this let me tell you multi value Boolean functions. So multivalued Boolean function is another my class related with substitution boxes. So lastly, we haven't required any kind of finite field requirement, and we haven't required the requirement of inverses. But here today we will discuss the requirement of Boolean while constructing Boolean function with the help of Galois field representation, Galois field. So if I recall that Z2 is 0 and 1, and then Z3 is 0, 1 and 2, I call it as a class. So Z4, that is 0, 1, 2 and 3. These are all modular classes. If you heard about these, so these are all modular classes. So these are, I must say this with, that is 0, 1, 2, so on, and minus 1. So I have these kind of what you call modular classes. So if I draw this this as like Cayley table, and I just construct like group a group is a non-empty set which satisfy 4 properties. Number 1, clear law. Number 2, we call it as a associative law, and number 3, additive law, and fourth one is inverse law or invertibility. So I must say a group, a non-empty set G is said to be a group if the following conditions holds. Number 1, closure law. I must say said to be group under binary operation steric if steric is any binary operation. If a clear law hold let x and y belongs to G, then x steric y also belongs to G. And second one, associative it has three elements, x, y, and z belongs to G, then x steric y steric z equal to x steric y steric z. I mean to say, all if you multiply first two elements and then multiply third one, and if you multiply first two and then multiply third, it is same. So in that case, we can say this set G satisfy the law of associativity. So let me elaborate this with another one, identity. Let x belongs to G, then there exists E belongs to G such that x steric E equal or E steric x is x. So inverse law. For every element in G, there exists inverse ठीक है। तो ये जो भी सेट नॉन एम्प्टी सेट ये चार प्रॉपर्टियां सेटिस्फाई करेगा उसको हम ग्रुप बोलते हैं। और अगर एक और प्रॉपर्टी सेटिस्फाई कर जाए, लाइक अगर मैं आपसे ये पूछूं कि एक और प्रॉपर्टी है कि अगर वो कम्यूटेटिव कम्यूटेटिव लॉ या एबिलियन यानी x y बिलोंग्स टू G हो, x स्टेरिक y या y स्टेरिक x अगर ये दोनों बराबर हो जाए तो इस केस में हम कहते हैं कि ये सेट G जो है ये कम्यूटेटिव लॉ भी होल्ड कर रहा है और सेट G जो है एबिलियन ग्रुप कहलाएगा। ठीक है, जिसके अंदर कितनी प्रॉपर्टियां पाई जाए? 5। ठीक है, तो इसी तरीके से एक और कुछ और स्ट्रक्चर्स भी होते हैं हमारे पास जिनमें एक से ज़्यादा हमारे पास बाइनरी ऑपरेशंस होते हैं। लाइक इट मे बी मोर देन 2 बाइनरी ऑपरेशन। लाइक अगर मैं रिंग की बात करूं तो इसमें लेट R be a non-empty set with 2 binary operation, like that is we can say R with addition and multiplication. Then R is group under addition and it is group under semi-group under multiplication, and 2 distributive law left and right, 2 distributive law holds. Then in that case we can say the non-empty, I just represent this R that is non-empty. It means it has some element. It should not be that's 5. It has some element. In that case, if it has 2 binary operations, that is number 1, the R is group under addition and under multiplication it is semi-group. In that case we can say this non-empty set, we call it as a ring. Moreover, if I can elaborate this with another one like field. field a non-empty set F is with two binary operation, that is addition and multiplication. ठीक है, is set to be a field if F is abelian group under addition and ठीक है जी. तो let me start with Z3. It is 0 1 2. ठीक है जी. तो मैं कैले टेबल का इस्तेमाल करता हूँ कि मैंने इसको चेक करना है either it is a field or not. So I have to use कैले टेबल. कैले टेबल में क्या होता है, कोई एलिमेंट रो वाइज या कॉलम वाइज रिपीट नहीं करना चाहिए. ठीक है, कोई एलिमेंट रो वाइज या कॉलम वाइज रिपीट नहीं करना चाहिए इस सेट का 0 1 2 0 1 2. और चूंकि ये फाइनाइट है इसलिए मैं कैले टेबल यूज कर रहा हूँ. अगर ये इन्फिनिट सेट होता तो फिर मेरे लिए कैले टेबल यूज करना पॉसिबल नहीं था. तो 0 + 0 0 0 + 1 1 0 + 2 2 1 + 0 1 1 + 1 2 1 + 3 3 under mod 2 under mod 3 under mod 3 which is 0. जैसे ही 3 या 3 से बड़ी वैल्यू उसको डिवाइड करके रिमाइंडर लिखना है. यहाँ देखें ऐड किया 3 आ गया तो 3 को 3 से डिवाइड करें रिमाइंडर 0. तो 2 3 0 2 + 2 4 after dividing it by 3 you will get remainder 1. So देखें किसी रो किसी कॉलम में रिपीटिशन है नहीं है, तो ये क्या फॉर्म कर रहा है, ग्रुप फॉर्म कर रहा है. Since there is no repetition, this implies there is no repetition in row column wise as well as row wise of the element of Z3. In that case we can say these form a group under addition. और अगर आप ये देखनी अंडर एडिशन या मल्टीप्लिकेशन कि ये अबिलियन है कि नहीं, तो आपने सिमेट्री देखनी है. लाइक इस प्रिंसिपल डायगोनल के अबाउट सिमेट्री देखें. 1 के क्रॉसपोंडिंग 1 है, 0 के क्रॉसपोंडिंग 0 है, 2 के क्रॉसपोंडिंग इधर 2 पड़ा है. तो इट्स अ सिमेट्री अबाउट प्रिंसिपल डायगोनल. So in that case we can say this Z3 is a abelian that satisfy the properties of commutativity. So we can say Z3 is abelian group under addition. Side is this abelian group under addition. So if I can say this, how it will behave when we take it multiplication. So in that way, dear student, if you can see this one, like if you can see this one, like under multiplication. So under multiplication, I have to take this what you call only take 1 and 2 because there is no inverse of 0. So whenever I use this Z3/0 excluding 0, it means I am excluding 0. In that case I just make the uh, like 1 2 1 and 2. So for simplicity, I just disregard the what you call eliminate the sign, but you have, if you want to place it, so you can place the sign of hat over here, because these are modulo classes. So I just remove these, but you can just put it over here like this one. So 1 into 1 1, 1 into 2 2, 2 into 1 1, 2 into 2 4, under mod 3 1. So you will have, so you can see there is no should be, there is no repetition of element of Z30 in row as well as column. And then if you can see the principal diagonal, there is a symmetry about principal. So Z3 is abelian under multiplication. ठीक है, तो इसी तरीके से जब हम और एक बात याद रखिएगा कि फील्ड के अंदर जीरो डिवाइजर्स नहीं होते, यानी हम दो नॉन जीरो एलिमेंट को मल्टीप्लाई करेंगे तो आंसर जीरो नहीं आना चाहिए। अगर ऐसा हो जाए, अगर जीरो आ जाए, तो वो दोनों एलिमेंट जीरो डिवाइजर्स कहलाते हैं। लाइक अगर मैं यहाँ पर Z4 उठाता हूँ, ठीक है, तो इस केस में मेरे पास 0 1 3 आ जाएगा। अगर मैं इसका टेबल अब ड्रा करता हूँ, लाइक ठीक है, तो मेरे पास इसका टेबल क्या आएगा, 0 1 2 3 0 1 2 3, तो 0 1 2 3 1 2 3, ये क्या हो जाएगा 2 3 0 3 0 1, ये क्या आ जाएगा 0 1 2। ये देखिए किसी रो किसी कॉलम में रिपीटिशन है, और ये प्रिंसिपल डायगोनल के अबाउट सिमेट्री आ रही है, 1 के अबाउट 1, 2 के अबाउट 2, 3 के अबाउट 3, ठीक है, 3 के अबाउट 3, नहीं सॉरी 2 के अबाउट 2, ठीक है, 3 के अबाउट, ठीक हो गया, और 1 के अबाउट फिर 1। So under addition, Z4 is again a abelian group। ठीक है, मेरी बात फॉलो कर रहे हैं आप लोग? तो इसी तरीके से जब मैं Z4 की बात करता हूँ, तो 0 1 3, ठीक, ये 4 है। अब मैं ज़रा इसको एक्सपेंड करता हूँ इस आइडिया को, और इसको ज़रा इस तरह लिख लेंगे तो चलें, थोड़ी स्टैंडर्ड नोटेशन आ जाएगी, ठीक है, ठीक है। तो 1 2 3 1 2 3 1 2 3 2 3, 2 into 2 under mod 4 0, 2 into 3 6 under mod 2, अच्छा 2 3 1। तो इस रो में रिपीटिशन आ रही है, इस कॉलम और इस रो में, और दो नॉन जीरो एलिमेंट मल्टीप्लाई हुए, ये कॉन्ग्रुएंट टू हो गए जीरो के। इसका क्या मतलब हुआ, 2 is 0 डिवाइजर इन Z4। जबकि मैंने आपको कहा था अगर कोई सेट अगर फील्ड है तो उसमें जीरो डिवाइजर नहीं होना, यहाँ तो जीरो डिवाइजर एग्जिस्ट कर रहे हैं, ठीक है। अब जरा हम ये देख लेते हैं कि इसमें से वो मेरे पास वो कौन से हैं, लाइक यूनिट एलिमेंट कौन से हैं। यूनिट एलिमेंट वो होते हैं जो जिनका इनवर्स एग्जिस्ट करता है, यानी यूनिट एलिमेंट फॉर ऑल ए बिलोंग्स टू Zn, अगर मैं ZN की बात करूं, ठीक है, मल्टीप्लिकेटिव सच दैट जिनकी GCD A की N के साथ 1 हो, यानी वो N के साथ क्या हो, रिलेटिवली प्राइम हो, ठीक है, तो उनको हम यूनिट एलिमेंट बोलते हैं। अब ये बताएं Z4 में मल्टीप्लिकेटिव की बात करता हूँ, ये यूनिट एलिमेंट जो है ना, ये यूनिट एलिमेंट, ठीक है, यूनिट एलिमेंट्स, तो ये इसमें 0 का 1 2 एंड 3। अब GCD ऑफ 1 विथ 4 क्या होगी, 1। अच्छा, GCD ऑफ 2 विथ 4 2, GCD ऑफ 3 विथ 4 1। किस किस के साथ 1, 1 और 3 के साथ। So this implies unit element in Z4 is 1 and 3, ठीक है जी, यानी वो एलिमेंट है जिनका इनवर्स पॉसिबल और 2 का इनवर्स पॉसिबल नहीं, ठीक है जी। So let me elaborate this one. So this is, so cryptographically we need that kind of invertible elements. So that is why my wholly solely the today lecture is how to get the unit element from the modulo classes, and I'm most interested in this. I'm least interested in defining the definitions of groups and field, and yes, these are just draw it with Keller table, but I'm quite most what you call interested to draw these kind of things, like uh, तो ये तो हमारी सारी यूनिट एलिमेंट हो गई। लेट अस से अगर मैं Z6 की बात करता हूँ, ठीक है, तो 0 1 1 2 3 4 5, ये अंडर एडिशन आप लोगों ने खुद चेक करना है, लेकिन अंडर मल्टीप्लिकेशन जब मैं इसकी बात करता हूँ ना, यानी 0 को एक्सक्लूड करके, तो इसमें आता है 1 2 3 4 एंड 5, ठीक है। तो इसमें यूनिट एलिमेंट क्या होंगे, Z6 0, ठीक है, इसमें यूनिट एलिमेंट क्या होंगे, 1 होगा, अच्छा 2 नहीं हो सकता, 3 भी नहीं हो सकता, 4 भी, 5 होगा, क्योंकि इन सब की 2 की 3 की 4 की जो GCD है 6 के साथ वो क्या होगी, like GCD of 1 with 6 is 1, GCD of 2 with 6 is 2, GCD of 3 with 6 is 3, and GCD of 4 with 6 is 2, and GCD of 5 with 6 is 1. So how many element was GCD? Greatest common divisor is 1 with 6. It has only 2. So the unit element is in Z20. Z6 is 1 and 5. It means it has only 2 elements in that set whose inverse is possible. So these are some what you call the unit element in modulo classes. So let me elaborate this with the help of another example, and just tending towards my uh, idea of how to draw the multivalued Boolean function that is based on you can call it as a which is based on invertible element. So if I can draw Z8, what is Z1, 2, 3, 4, 5, 6 and 7? this is a abelian group under addition. But if I can draw the Z8 0, I mean to say excluding 0, 3, 4, 5, 6, 7. So in that case, if you can draw the Kelly table of the Z8, in that case there will be a 0 divisor. So I have to select unit element of Z8. Sometime I can write it down like this. So 1, 3, 5, 7. These are 4 elements whose inverse are possible in Z8. So if I can say the inverse of 3 under 8, 3 into 3, 9, and under mod 8, 1. So 3 into 3 is 9, and it is congruent to 1 mod 8. And 5 into 5 is 25, it is congruent to 1 mod 8. And 7 into 7, it is 49, which is congruent to 1 mod 8. So the inverse of 3 is 3, inverse of 5 is 5, and inverse of 7 is 7. Because we have the property of inverse, and if you can multiply this with, you will get under mod n. These are something we needed quite what I should say badly in cryptography is this. So these kind of unit element are quite necessary and quite important, and while you are discussing cryptography. So let me elaborate this with some number theoretic functions, how you can devise these. So if I can do it like how many unit elements over here, in that case there are only 4 unit elements. In case of Z3, you have what you call it as a, you have only 2 unit elements. If I can draw this Euler file function, so you can say this Euler phi function, like if number 1, if n is p, I mean to say your modulo class is z, and I mean to say z is p. In that case, phi of n is p minus 1. That basically Euler phi function give you directly the result and how many unit element you have in certain modulo classes. Like if you have z3 0 1 2, so multiplicative, I mean to say that it gives you the multiplicative unit element, number of multiplicative unit element. So if I can say Z3, it means here P is what? P is 3. So 3 minus 1, 2. You have 2 unit element. वो यूनिट एलिमेंट जिनकी GCD 3 के साथ 1 होगी, ठीक है? तो let me elaborate this with, if I have n is p to the power I, so in that case you have phi of n, p of I, p of how many do you have? Let me elaborate this with. Let me elaborate this with one example. So let me, if you have p to the power n, say if you have some number like n, like which is can be written as p to the power I. So in that case, Euler phi function will be pi minus 1 into p minus 1. So I mean to say, if I elaborate this with the help of like how many elements are there in the in case of if I have Z8 like 2 to the power 3. So how many elements are there in Z8? Yeah, I mean to say 2 to the power 3 minus 1, 2 minus 1. So it gives me 4 and 1, 4. So in that case, my P is 2 and I is 3. So we have 4 element whose inverse is possible in Z8. Okay? Z8. Another case, third one, if any number which can be written as a product of prime, which is what you call the fundamental theorem of arithmetic, that any number greater than 1, any non-zero or any positive number which is greater than 1 can be written as a product of prime. So I can just write it down. Phi of, that is, if I apply phi on both sides,